This is my real picture. I'm photoshopped here. I created hundreds of interfaces in the HL7 world, CDA also, and also I taught CDA, V2, and FHIR to over more than 6,000 students. I'm from Argentina, so my English is not from London. You will notice that. And I also do affiliate mentoring, so I facilitate creation of HL7 affiliates all over the world. And I created 8 FHIR implementation guides in the last 4 years. So we will talk today about the FHIR safety checklist. This is not a security class in the sense that we will do hacking of servers. We will not do hacking of servers. If someone is expecting to hack servers, get out. We don't want you. So, have you read the FHIR? How many of you have read the FHIR safety checklist? None. That's, you have like half of it? Because when you begin to read it, you begin to do, oh, no, and you.
That's why I stopped at that.
Yeah. I only read it to do this. So finally I read it. It's very, very, very important. Don't read it now. But that's if you ever want to read it, it's here. You will find out that it's important. So we have 2 sections for this class. The first one, we will review the checklist. In fact, I reviewed the checklist. So you will see my review. That's the first part. And in the second part, we will go through a real project. I brought to you a project, working project, that you need to review using the checklist. So that will be the second part. So if you don't pay attention to me, you will not be able to do the second part. You have to pay attention to me all time. So the first question is, what happens if you don't follow the FHIR safety checklist? You haven't read it, so what happens if you don't follow it? The first thing is death. You will die eventually, at some point. Then hunger, and then war. All of it. Well, no, not that, but some things may happen. And when some things may happen, we refer to that as risk. Which are the risks? What happens if I don't do this? So what we are going to find out are the risks. So my methodology with this class is to use this callout for you to think. This is a think callout. So you have to think what will happen if I don't do this part of the safety checklist. Or maybe we can think together. And this is, when you have a risk, you have to have a plan to mitigate the risk. So this is my mitigation, my plan to mitigate. So for each part of the template, I created for you a risk and a mitigation. The final saying is not my presentation. Don't just use my presentation and forget the actual checklist. It may happen. The problem is that the checklist is like wearing a watermelon collar. I don't know if this saying applies here, but think about wearing a watermelon collar. When you read it, it's like that. So we have to work on the checklist. So there are 7 sections. We will go through them. Security, privacy, deletion, search, other, conformance, and daytime. Other, where they didn't think about a title for that, and they put everything together there. So let's review it. The first one is privacy. Under privacy, you have 2 concerns. The first one is patient consent. And patient consent is usually in the law. of the regulation. So it's under IPA in the States or GDPR here. In every country, you have a different regulation. So you need to be sure that the consent was granted by the patient. What this means is that he's okay or she's okay with you sharing your data with other parties. That's the meaning of consent. In some place, the patient says, okay, I will share it. In some places, the patient sign something. Usually right now, with Argonaut, the patient needs to give the consent right when he is entering the system, the app. He says, okay, you are sharing your information with someone. But this differs in every part of the world, every project is different. So what happens if you don't do this? If you don't have proof of consent, you will have a place in the news. It happens last week to Google. Have you read the news about this? You read the news? Okay. Last week, Google was discovered to be in a project with a very big payer in the States, and the title of the newspaper says, Google has access to patient data without consent, which may be not true, but that's the headline. So be sure that you have consent, some way of consent. For instance, in my country, we have a big project, a big project, and we are doing opt-out. What means opt-out? You are in unless you say you are out. It may be partial, so I'm in for some data and I'm out automatically for other data. It can have granularity, so you can do, okay, if it's data about my sexual health, I don't want no one to know, only my doctor. If it's about drugs, I don't want anyone to know but my current doctor. If it's about my diet, you don't want to know. Storage. How do I save this consent? If the patient says, okay, I want to share, that statement has to be saved, stored somewhere. And there's a Fire resource for that. So you can save it using Fire in your server. And it has to be simple, and the patient has to understand it. The problem right now with consent, sometimes it's very complex. For instance, in France, they have this big project, and they have this grid of 20 document types and 20 different practitioner types. And they have to check in the grid. Nobody understands. So consent has to be something understandable, maybe 3 colors. I consent in the this general way. I don't consent for pharmacy companies. I don't consent for marketing. Or maybe I consent for this type of data, but don't for this type of data. Very simple. Because if you don't do that, the patient will not be able to understand. And the other privacy issue in the checklist is the accounting of disclosure. So you need to know when some data was shared and who read it. And you means your system, but you means your patient. Your patient needs to know too. And why we say that the patient needs to know? Because usually, if you don't have audit log and you don't review your audit log, you will find out about the breach late. So if you don't record who is watching and you don't review these records, you will find out about breach later. And the best way is to tell the patient, because if the patient knows, they may find out that something is wrong. If you receive a mail every time a doctor sees your record, and you say, okay, this is not my doctor. Why is a doctor in Russia looking at my records? So if the patient will find out sooner. But also you have to do a review of all the records to see patterns that are not fine. For instance, a physician looking for tons of records in the same day. What is he doing? How many patients he sees? Why is this physician looking for the records of Madonna? He's not attending Madonna. You have to review your audit log. Every day, you have people reviewing it. So you have to record audit event. Audit event is also a file resource. So you can record both consent and audit event, audit log in Fire. So you have to send alerts to the patient, you have to analyze the logs, and you can discover patterns and outliers. So everything okay with this slide? This is a little technological, little wire-oriented. So on security, you have also to ensure that the clocks are synchronized. If you don't synchronize your clocks, weird stuff can happen. So this is the protocol for synchronizing, because chronological order is very important in clinical evaluation. If not, you can be leaving your room before entering if your computers are not synchronized. Because one will tell, okay, 10 a.m. the patient leave, and the other will tell 10:02 the patient entered. So your computers need to be synchronized. This is very easy, and it's just infrastructure. And the other one is very important, it's encryption. Encryption on the wire, encryption of emails, encryption of everything that is in movement from one computer to another. And also very important, I've seen a lot of projects that store credentials in plain text. Please don't. Don't store credentials in plain text. Nowhere. Also, I saw a lot of credentials in Amazon. In plain text in Amazon. Please don't. So if you don't encrypt, this guy will look at what you are transmitting. Not a nice guy. He can actually see what you are sending or receiving, even change it. In the past, remember I'm old, we were protected by the hospital walls. Inside of a hospital, everything was secured. No longer. Nothing is secured. Because I can bring my computer and I'm connected to my phone with my friends in Russia or whatever, or in Thailand with eVout, and I can send eVout all the data from your hospital because I'm connected to the hospital and to eVout, who is hacking from Vietnam. So we are no longer protected by the walls. There are no walls now. The actual walls were okay because we use cables to connect to the equipment and between us, actual physical cables. Cables are not longer with us. Next one. Are we okay with this? The second? The third one, authentication and authorization, different stuff. This is about who you are. Is it okay that you are accessing these records? So you are you. And the best way is this one, to have this thing called OAuth profile, which is described in Smart on Fire. And this is what the checklist recommends. So in this scheme, you have a two-step access to the resources. First, you have to authenticate to a server and say, okay, I'm me. Give me a token. And with the token, I go to all the resource servers and say, I want this. So the token says who I am, but also what kind of access I have. So I can read patient information, I can read condition information, I can read allergies. This is the combination of authentication and authorization and access control. This is first who I am, and then what can I do? with which resources. So what happens if you don't do authentication? Everyone can access whatever they want. And what if I don't do authorization? Once you are in, you can enter whatever you want. The first is I go in the system. Then, what can I do with my level of authentication, of authorization? So the patient should authorize not only the persons, but also what they can see in the patient records. The other part is something called role-based access. And role-based access is that some kind of resources require specific permissions. For instance, I can see clinical information about the patient, but I cannot see sexual information. And that is, you get to that type of level of granularity using security labels. In each resource in FHIR, you can put a tag, a special tag, saying, okay, this one is not a regular condition. This is a more confidential condition. So you have to take in account that in your app to make sure you don't show some security label, some resource with a specific security label. So you have to check scopes, you have to check roles, and you have to check security tags for every request. Yes?
Are the security tags part of the standard, or is it just like some tag custom?
They are part of the standard. They have a specific definition, but you can do your own. Usually, every project defines its own. But there are some definitions in the standard by compartment, and even at the resource level, every resource has a specific security level. But these are for special. These are special tags that you will put in your resource to make sure that everyone knows that this resource is special.
It says that security tags can be applied to bundles, but obviously there are lots of different kinds of bundles in the system. So, and what is the solution for this kind of information?
Usually what we do, if there is in some place of the bundle is a very specific tag, we escalate it to the whole bundle. This is my policy. If I have something, you have, this is normal security, this is normal security, this is normal, but this one is, wow, this is not normal. Then everything should be not normal, because we are bundling together. That's my policy. About integrity. So we need to render narratives properly and securely. You know, every resource in FHIR has a narrative, something that is written that everyone can read without going through the details in the resource. So, and this must be shown to the physician. And it must be shown securely. And what does it mean to show it securely? It means that since the tags are XHTML, you make sure that it's clean, that it will not harm you. And here is an example of harm done. I will show it later. So you need to not allowing active content and watch your URLs. So when you have a resource from somewhere else, you have to clean it. You have to make sure that it doesn't do any harm. And you have to differentiate between what is coming to the APIs and what is coming from the browser. And the other stuff is that you need to use provenance. There's a class about provenance today. And provenance is the form that FHIR has to say where this information comes from. It can be applied to anything in FHIR. So you have patient information, you have an allergy, you have a condition. Who says that this patient has this condition? This hospital, this physician in this date. Maybe the patient himself. That's provenance. It's where did I get this information from? And the safety checklist recommends using provenance, but nobody does right now. It's something that we are baking into our systems because there is no clear consensus. But I think this year, everyone will start using it heavily. So you have to use provenance to record. If you save information in your system and somebody else sent that information, you have to record where did you get that? Who said that? So this is the thing about this render. You can create something like this. Attached to that image I showed you before, and this will send all your headers and all your content in your browser to someplace else. And you don't need to click it. So this is a known hack to CDA XSL, and Fire XSLs are the same, but they are sanitized now. About conformance. So the first thing is to ensure that you have a life cycle and you know what is current. Life cycles is about each resource. How is it? Is it active? Have they deleted it? Is it on hold? Since everything is so easy in Fire, you may forget that things have a life cycle. And maybe you are showing stuff that is no longer current in your app. So make sure you're not doing that. And the other thing is, what is current? For instance, if somebody has diabetes from this date to 2 years before now, it's not current. So if somebody asks you to give the list of current conditions, don't return that. If somebody was taking some medication 3 years ago, don't return it in the current list of medication. And don't show it to your patient in your app as a current condition. This is stupid what I'm saying, but we are doing that. We are stupid. And you have to publish a capability statement, usually for servers. And this is who you are as a server. You cannot create a Fire server without publishing this in your server. What resources do you cover? What operations on your resources? If you don't do that, you are not a Fire server. So this is the first thing you need to do. And it has to be faithful to what you do. Also, you need to publish your value set. Which codes are valid for your system? If you don't do that, and I may not know what to send to you in order to have a valid resource. So if you don't do this part, you will end up doing this. This is patient Dave's, who was here in the morning. This is a blog he wrote in 2008. And this is the list of his problems or conditions at that time. And what they do was to create a list of everything he was billed for in his life. And that was his conditions in Google Health. He hasn't that at that moment, only maybe 2 or 3. So he created a blog about this. No one can have all of this at the same time. And there are no dates. This was an actual screenshot. This is what we are talking about. This is not safe for the patient or for anything. about conformance. So there are 3 different types of elements in FHIR that are very important. You will have all the slides. Don't worry. You don't need to take pictures. 3 different types of elements: modifier elements, modifier extensions, and must support elements. Modifier elements are elements that modify the resource itself. So if it's conditioned, for instance, and it says status, you cannot ignore that. That's a modifier element. Modifier extensions are things that people creating the implementation guide created above what the resource definition is. So I think this is my resource. It has name, address, whatever. And I created a very special extension for my country, which says something that my country thinks is very important. And you cannot use the resource if you don't read that. That's a modifier extension. Something outside of the standard, but I think it's very important. If you are reading modifier extensions and you don't support that, you have to reject the resource, because you don't understand the resource. And the must support element is something in the standard, but people creating the implementation guide says you have to support this element. As a server, it's very easy, because you have to include it when they ask for information. If the implementation guide says this resource, gender is must support. Gender is must support. So you as a server need to populate gender every time you send this resource to someone, because that's must support. But as a client, what do you have to do? As a client, you have to show it, because what your responsibility as a client is to use it for something. You have to show it, and you have to store it in your system. And how can we make sure that you are storing it? Because you can show it later. So if I'm inspecting your product, I will say, this is must support. Where are you showing it? Well, I will. No, you are not supporting it. If you are a client, you must show it. So you have to always process, store, and render modifier elements, modifier extensions, and must support elements, because they may change the meaning of the resource. And this is an example. Suppose I have a not do it extension, and I have a medication, and I have this resource. This medication, please do not give to this patient. I don't care about extensions, and I kill him. Not good. Okay? About error checking. This is not me, this is a checklist speaking to you. So, you have to be aware of the errors. Always do try catch and control your errors. I don't know which language you write on, but every language has a try catch. And the catch should do something. Don't do empty catch. You know what empty catch means? Yes. Empty catch is bad. About conformance again. Validation of resource. Every library allows you to validate the resource once you are getting it. You get your resource, and you can validate. Usually, if you validate in production, you will lose time. Maybe you cannot do that. But make sure you validate a lot during testing. Because after that, usually things go kind of good. I'm not promising. I'm old to promise heaven. But you're mandated to validate before production. The problem with validation in production is you may have legacy data, and legacy data will never validate. So you have to be aware of that. A nice discussion this week will be how to validate against a series of profiles that is changing. Because we are still in the creating new profiles and rolling out new implementations. What will happen a year from now when we create new profiles? And this set of profiles is old, but there will be hundreds or thousands of systems using them. They will be not valid for the new profile, but they will be valid for the last profile they were used when they were created. So this week here, you will discuss this. What happens in production with several profiles. And remember this. You should be conservative when sending and liberal when receiving. So be gentle when you are receiving. If you cannot receive anything because you are too strict with your validation, you are worthless. It doesn't work that way. You have to be gentle. And you have to be conservative sending. You have to try to make everything right. You have to try to validate before sending. It's not mandatory. And this is very, very, very interesting. Focus in observation resource. The whole standard has hundreds of resources. And somebody told us, look forward for this focus in observation resource. Observation resource is something about the patient. This patient has this, or we have measured this, or have this lab result. And they say, watch out for focus. What is focus? Focus is maybe it's not the patient observation, it's other thing observation, which is related to the patient. For instance, this liver has hepatitis. But it's not the patient liver. It will be the patient liver. It's related to the patient. Or the patient father has this condition. It's not the patient. So if you attribute the patient, you are wrong. So you have to watch out for focus in observations. I have never done this. It's wonderful. It's wonderful. So you may end up, suppose this is a patient room, and I found the bacteria here, and this is in the patient record, but the patient has not that bacteria. It's about a wall in the hospital, but this is the patient bed, something like that. Contain resources. You can reference resources, like this is the resource pointing to another elsewhere, or you can put everything together inside of the resource. That's contain. But once you do a contain resource, you cannot access it outside of the container. So this is good, but you have to be aware of when to do it. And this is very important. Distributed resources. FHIR is about this, about distributing information and having stuff in different places and maybe keeping copies of this stuff because it's faster to keep a copy. But what happens if the original changes? Do you know? So this is key. I think this is the most important part of all the safety checklist for me. Knowing where is the information and what happens if it changed. And I created a word for this. It's called in FHIR structure. Because we are doing our infrastructure in FHIR. Everything. I invented the word yesterday and Graham authorized me, so I will use it. So what are we doing with FHIR? We have a master patient index. We know which patient is which patient. We have a terminology server where we ask the server, what is the code for diabetes? What is the code for something? FHIR 2. We have a validation server, structures, value sets, and code systems. We have registries for practitioners or providers. We have document repositories and registries on FHIR. We have a consent registry. We have an audit log server. and we have authorization and authentication, and then comes your application. First, you have to do everything, and you have to know where is the stuff there, where to find the stuff there, and what happens if this patient changes to my server. Does my server know? I have a cache of information. I have a copy. What happens if the patient is deleted there? Do I find out? So for people saying that FHIR is simple, look at that. That is FHIR. Maybe not today, because we are using legacy for some of this stuff. But we are in the process of either facading that legacy. You put a firewall before, and you think that everything is FHIR, but it's not inside, or creating brand new products to do that. We are almost there. Deletion, you have to handle deletions and replicate it, as I told you before. I'm not doing every box here because you can read it home, so you can read it later, and you will remember at least what is in the slide, not what I said. And you have to document what happens if you delete, because some systems cannot delete, or some systems do something special with deletion. So you have to document in your server. And you have to be aware as a client that deletion exists. About searching, you have to ensure that the server supports your search parameters. Why is that? Because when the server, usually most of the servers, the FHIR servers that are around, ignore what they don't understand instead of throwing an error. So I will tell his server, okay, give me all the patients with glucose less than 1,000 and a condition of whatever, and he will tell, okay, this is the list. But he doesn't understand my search. He just threw me whatever he had about the patient. That's the whole truth. You can test it. He will ignore my search parameters. So you have to be sure that the server knows what you are talking about. And if the server doesn't, you will have to filter from the server's return. So you have to reapply if the server cannot. So these slides recommend the server to detect the mismatches and to raise errors instead of returning whatever they want. And this is about the client. Beware of this problem. I have 2 minutes. Daytime, you have to ensure that your server knows daytimes, especially time zones, and also the syntax in the time format for your users, and also decimal points and culture. This is not for FHIR only, it's for everything. But it's important clinically, because, for instance, in some countries you have 5 hours of difference in the daytime, and the patient is traveling. When was the first time the disease was detected? It was 5 hours ago or 2 hours ago? It's important, it may change treatment.
Yeah, and the time changes as well, like autumn and
Yeah.
back.
Yes. And let's do the last one. You have to handle CORS, which is something in browsers that protects you from attacking a server when creating petitions. You have to support that CORS, and you have to support JSON. Because some servers only support XML, that's wrong, because most developers use JSON now. You cannot support only XML. So if you develop in JavaScript, you have to be CORS aware. Reference servers in FHIR right now, there are like 20, Some of them don't support core, so if you program in JavaScript, your program will not work at all with these servers. And if you are a server, make sure you die gently on errors. If you fail, you have to return, I failed, and this is the cause I failed. Not dying. Dying is not civil. And this is my last slide. This is a famous phrase, do not wish me luck, give me a checklist. Fake Albert Einstein. So what I gave to you is a safety template for you to use in your project. It's here. This is, I'm not showing it. So this is what we will use in the next session. This is a project, and you will have to review all the project to see if it abides the checklist. The project is fake. I created it. It's in production in 100 hospitals. And everyone is seeing everyone's record. So you will have to, this is a gift I give to you for your project. How many of you are agile, in agile projects? How many of you program? How many of you are in agile projects? How many of you have a definition of done? Definition of done. How many of you think that in a fire project, nothing is done if you don't do this? Nothing is done if you haven't reviewed the safety checklist for even a feature. This is my new thinking about it. Yes?
I can't read it. Is this the fire safety checklist as on the fire website?
No, this is my version for you. It's a gift.
But is it, so it's different?
If you have to use the checklist, the actual checklist to do this, you cannot, because it only has something like this, and you cannot use it. Why are we publishing something that we cannot use? So this we can use.
I don't understand. So why can't we use the online checklist?
Because it is not a checklist. It's a series of paragraphs.
Okay.
This is a checklist.
Okay.
This is what we will use in the next session to review a project. Okay? And you are invited to review your own projects. Are we done? Thank you.